Hi everyone, welcome to the final video in this series. We're continuing on from what we talked about in the last video, which was line of best fit, and we are now applying what we've learnt to answering a couple of questions. So the first question here says, consider the variables x and y and the corresponding bivariate data. So we've got this table here and we want to draw a scatter plot for the data. So I've come up with a little xy axis here, and we want to plot all of these points on here. Now, the first one is 1, 1. So when x is 1, y is 1. So that's going to go here. And we have 2 and 2. When x is 2, y is 2. That's a different point. We also have the next one here. When x is 3, y is 2 as well. We have this one here when x is 4, y is 3. And we have 5, 4, 6, 4, and 7, 5. So 5, 4, 6, 4, 7, 5. Okay, so we have a scatter plot that looks like this. This is all we have to do for question A. It's done. We're just plotting all of this on. Now, part B is asking us, is there a positive, negative, or no correlation between x and y? So we can clearly see here that as x goes up, y goes up as well. We can see it in the table of values, and we can also see it when we actually draw it in. So as x gets bigger, y gets bigger as well. And when we have this type of relationship, we called that a positive relationship. So for part B, there is a positive correlation between x and y. Now part C says find a line of best fit by I on the data on the scatter plot. So if we draw this in, we're going to get roughly, now forgive me, this might not look as good, but let's try our best. That's not bad. There we go. Okay, this is probably the best you're going to get with something like this. Now, obviously, you guys can hopefully use a ruler, so you'll be able to draw a more straight line. But we can kind of see we've covered all the bases here for what we talked about in the last video of plotting a line of best fit. We've got a couple of points that lie on the line, and we've got an equal number on either side. So this is a pretty good scatter plot. Well, sorry, a pretty good line of best fit for this scatter plot. So now we've drawn this line of best fit by I, and we can use this now, since we have a line that we're going to attribute to these points. We're going to use this line of best fit to estimate a couple of different values here. So the first one is we want to find y when x is 3.5. So what we want to do is we want to locate 3.5 over here, which I guess is roughly here. And we want to draw it up to our line of best fit. And then from here, we have a point, and we're going to use this to find an approximate y value. So this looks like it's a little over half. So we can say this goes to about 2.7. So we can now use our line of best fit to estimate different data points based on the linearity of the current ones. So finding y when x equals 3.5, that is about 2.7. Part 2, it's asking us find y when x equals to 0. Now we want to extend this one a little more. And if I draw this down, I get down to about here. So when x is 0, so here's 0 on the horizontal, my vertical is going to be, that looks like about 0.3. Now remember, these are just approximations. So the line of best fit, it's not a foolproof measure or thing. It's really just looking at determining trends between two variables and then using this to make some predictions. Now the next one, so that's about, we said 0.3. For this next one, we want to find x when y equals 1.5. So when y is 1.5, let's do this in a different color. It's about here, and we're going to draw this along until we hit our line. And we're going to draw this down. Okay, now that looks like it's just before 2, so I'm going to say that's about 1.9. Remember, these are just approximations, and you'll get it probably more accurate approximations the more linear your line is and the better you draw it, but we're really just trying to understand how these two work. So finally, we want to find x when y equals 5.5. So let's locate 5.5 here. That's about up here. And we're going to draw a line all the way across until we hit this. Now I need to extend my line of best fit a little more so we can determine where exactly this crosses. But we see it goes about here. And if we draw this down, I'm roughly at about 7.8 here. So the value of x when y is 5.5 is going to be 7.8. So this is how we can construct a scatter plot, which we've been doing in the previous few videos, determine its correlation, draw a line of best fit, and then start to approximate different data values along here for different variable sort of values. So in the second question, we're already given a scatter plot, and this shows a linear relationship between English marks and literature marks in a small class of students. So a trend line passes through. Now remember, trend line is another way of saying line of best fit. Passes through 40, 30, and 60, 60. We want to find the equation of this trend line. So we got this point here and this point up here, and we want to find the equation of this. Now, looking back to what we learned in linear relationships, we recall that we can find the gradient by taking between 2 points, finding the rise and the run, and the gradient is just rise over run. So it's my rise over run, which we can also write as one arbitrary y value, let's call it y2, subtract a different value, because finding the difference between y values gives us how much it's risen, and then we do the same with the x values. So let's just say this one is y2 and this one is y1, and that's x2 and x1. Okay, so substituting that in, we're going to get 60 minus 30 over 60 minus 40. 40. Okay, so that gives us 30 over 20, which then finally simplifies to 3 over 2. Now, we found the gradient of my trend line, of my line of best fit, and we want to use this to find the whole equation. Now, we remember that all lines have the equation in the form of y equals mx plus b, and we have a value for m that we found. So we can say that my y equals to 3 over 2x plus b. Now, the missing thing is this b that we want to find, but we can use either of the 2 points we're given and substitute this in to find the intercept. So we've done this a lot for in linear relationships, so we're just revising that. So I'm going to choose to do the point 40, 30. So this point here, I'm going to substitute that in there. So when x equals to 40, y equals to 30. So instead of this y here, I'm going to put 30 equals to 3 over 2, and that's multiplying by x here is 40 plus b. And then I get, so 30 here equals 2. Multiplying these two out, I'm going to get left with 60 plus b. and then I just want to subtract 60 from both sides. I'm just solving the equation now to get to a value for b. So I get negative 30 equals to b. So I have my b, I found my m from the previous part, so I can pop those into my equation of a line. So I get that therefore my equation is y equals to 3 over 2x minus 30. So this is the equation of my line. And now what we're doing is, using this equation, we can predict a few points here. So what we're doing here is we're going to be working with the two definitions we learned before, interpolation and extrapolation, and see how we can apply those to this particular question. So we're trying to find in part, get rid of this stuff, in part B, what we want to estimate the literature score if the English score was 50. So we want to find 50 in the English score, that's down here, and we want to draw a line up to here, and then draw it along to here. So I'm going to say that's around 45. So we can say that we approximate the literacy score, or the literature, sorry, score to be around 45 when the English score is 50. Now, have a think, is this an example of interpolation or extrapolation? Well, the point we looked at, 50 as the English mark, lies within this data set. So we can say it's inside the range of values. So this is interpolation. A good way to remember it is inside or in interpolation. We're looking at those values within this range. Now the next one, we're trying to estimate the literature score if the English score is 45. Oh, sorry, is 86, my bad. So 86, that's about here. So we're going to draw this up. And as you can see, well, this is quite clearly extrapolation, because now we're working outside of these data points, and it's a little risky to extend my line. It may affect our accuracy. The good thing is, now that we have our equation, we can just substitute the value of 86 into the English mark section, which in this case is my x variable. So what I'm going to do for part B, when we can't draw it on our graph, what we're going to do is we're going to substitute x equals to 86 into our equation. So in doing that, I'm going to get that y, my literature mark, is equal to 3 over 2 times 86 minus 30. Okay, so once I do that, I'm going to get 99 as my answer. You can check this on your calculators. But we can pretty clearly see we're extrapolating this, so we're looking outside. 99 in my my y is about up here on my graph. So once again, my y value and my x values are both extrapolated. We can only get them if we were to extend this line of best fit a little further up. So we're looking for values outside of my data range. We are extrapolating in this example. But there's two ways to do it. You can either, if it's interpolating, you can look at it visually, try to estimate it, but you can also just substitute it straight into the equation. Some of you may prefer the equation because once we have this, we can just substitute and it becomes a lot easier to work with. Now let's do the next couple of questions. Here, we're trying to find some English scores when given a literature score. So for the first bit, it's telling us to use our equation to estimate the English score if the literature score is 42. So we're looking at the literature score now, so we want to substitute in for the y. So for part C, we want to sub y equals 42 into the equation. Okay, so in doing that, I'm going to get that 42 equals to 3 over 2x minus 30. And this just becomes an equation that we have to solve. So we're going to add 30 to both sides. So I get 72 on the left-hand side. So 3 over 2x. Okay, and then I can just divide both sides by 3 over 2 because these are multiplying on the right-hand side. So I can divide both sides by 3 over 2. And I'm going to get left with x equaling to 48. Cool. So this was done by substitution. You can also do this on the graph because, once again, this is an example of interpolation. So if I were to have a look on my graph, 42 sits like about here, really close to 40. So I can draw it along, and if I go down, I can see it's very, very close to 50, so that would give me a pretty good approximation as well. So this value was 48. And finally, we want to estimate the English score if the literature score is 87. So once again, we can substitute this into the equation. You can look up here, but it looks like 87 may be extrapolation again, because we can't quite, 87 would be about here. We're looking at above the actual data points and the range that we've established. So for this one, let's just substitute it into the equation. So here my y is going to be 87. So I can write here for C part II, y equals to 87. So I can say that 87 equals to 3 over 2x minus 30. And I'm going to move through this a little bit faster because now we should have the idea and know how to solve some equations. But now dividing both sides by 3 over 2 gives us 78. So we can say, therefore, the English score is 78. And the same thing up here. So the English score is 48. So now we are applying the things we've learnt the theory on. So we've now established all of the linear relationships, kind of background information that we need. We understand interpolation and extrapolation, as well as graphing data points, drawing up a line of best fit. The essence of this video is that now we can start looking at making predictions and estimations. So now that we have a line and a linear relationship between the variables, if we can draw a line of best fit, then we can start trying to make some predictions about values that either lie inside of our data set, interpolation, or outside of our data range, which is extrapolation.